Welcome to the Managing Replication and Failover lesson. The lesson objectives are shown in the slide. This is the About Sites and Replication topic. Replication causes data to be transferred or forwarded to another SEPM. A replication partner is another SEPM that is associated with the local site. Changes in groups and policies, and if configured, logs, client packages, and content updates made on any replication partner are replicated to all partner sites. This slide shows three sites. The Munich and Paris sites replicate with London. However, they do not replicate with each other. Changes from the Munich site are replicated to Paris, and the reverse is also true. This is because London receives the changes from each site, incorporates the changes into its database, and replicates the changes to each partner site. Because replication takes place between the SEPMs, database types are independent, which enables a mixture of databases within the replication scheme. For example, your environment can include supported versions for MS SQL 2008, 2012, 2014, and 2016. Replicating data between sites enables you to centrally manage policies, reporting, and log data. You may require a consolidated management structure, have legal reasons, or have the need to schedule data across a WAN based on bandwidth. The local site always refers to the SEPM to which the current console is authenticated. The SEPM on this site may be physically located elsewhere, but it is still referred to as the local site. Remote sites are accessible in the console as replication partners through the SEPM console admin page. This is the How Replication Works topic. After sites are created, the databases associated with those sites need to exchange data. When replication partnerships are established, the SEPMs exchange data so that the databases are effectively synchronized. You can schedule replication to occur at off-peak times when network bandwidth is readily available. After replication partnerships are established, the site administrator credentials are used until the SEPMs exchange digital certificates. After the certificates are in place, replication communication is validated using the certificates. By default, replication traffic uses HTTPS on port 8443 to transmit data. Due to the potentially sensitive nature of data being transmitted, the traffic is encrypted while being replicated. You can use the Management Server Configuration Wizard to reconfigure the default replication port. What is replicated? Database container. For replication, data is categorized into data types. Groups represent the group architecture that is created on the client's page. Policies are all policies currently defined by the SEPM. This includes policy components and any policies currently in use, as well as those that are not assigned. Content updates include virus definitions, all signatures such as IPS and proactive threat heuristics, patches for clients, and so on. Client packages are the packages for client installations that are defined on the admin page. Logs are from all components in the database. The replication container. The replication container is a term that refers to a set of replicated data. When replication is performed, the different data types to be replicated are grouped with other similar data types. Groups and policies are replicated together. Client packages and live update content updates are replicated together. Logs are replicated separately. On the initial replication, group and policy data and client packages and content updates are replicated. When you configure the replication schedule, you determine what is replicated for subsequent replications. By default, policies, policy components, and groups are replicated in both directions and cannot be disabled. Client packages and live update content are optional for replication. However, when selected, they always replicate in both directions to avoid issues with inconsistently applied content updates, such as virus definitions. Logs are optional for replication. They are the only data type that can be replicated in one direction. All clients are registered, and the registration is kept in the database by group. After a site completes replication from another site, the site sends a notification to the other site to begin replication from the originating site. Replication starts in one direction first, and when complete, replication begins in the reverse direction. For example, when London replicates data to Paris, Paris receives the data and merges the data into its database. Paris compiles any changed data that is to be sent to London. Paris notifies London that there is data to replicate. Unidirectional replication is one way from one site to another. You can only replicate logs in this manner. For example, an administrator may decide that London is a central repository for all logs and only replicate logs from Munich and Paris to London, but these logs are not replicated to Munich and Paris. Conflict can occur in database replication when administrators at two different sites create the same resource. For example, if the same group named Sales is added to both the London and Paris sites, when replication occurs, the groups are in conflict. Each group is assigned a different GUID, called a unique sequence number. When each SEPM receives the sales group from the other, each SEPM examines the time and date of when the group was last changed. The group changed most recently has a ~n appended to the group name. This means that both London and Paris now have a sales and a sales ~1 group. The letter N represents the smallest number that does not make the new group name a duplicate. During policy changes, if changes are made to the same policy from two different sites, the most recent change is kept and the other change is discarded. All data in the database is associated with a timestamp. From the timestamp, the SEPM determines that data has changed since the last successful replication with its replication partner. This allows the SEPMs to only replicate content that has changed, which reduces bandwidth requirements. This is the Symantec Endpoint Protection Replication Scenarios topic. There are several configurations that can be used to replicate data between the London, Paris, and Munich sites. In this topic, the following replication scenarios are described: basic replication, centralized management, distributed management, centralized logging, client packaging and content. Basic replication is the replication of policies and groups. When you configure replication, policies and groups are replicated by default. All change detection and merging of data inside the database occurs at the row level. This means that if a piece of data is changed, the database does not replicate the entire table, but replicates the specific rows of the table that contain the changed resource. Centralized management. When multiple partners are in the replication chain, all partners converge on group and policy changes. In this example, London is acting as a hub for changes to the other sites by replicating only groups and policies with Munich and Paris. Depending on how many sites are configured for replication, it may take several detection and merge cycles for changes to progress across the entire infrastructure. For example, where changes are made at both Munich and Paris, London and Munich replicate first. After replication, London and Munich have matching policies and groups. London and Paris replicate and contain merged data from the entire architecture, while Munich contains only the merged data from itself and London. When London and Munich replicate, the third replication for London, the changes from Paris are merged into Munich. This scenario shows how it can take several replication cycles for a sequence of changes to result in a consistent configuration across all sites. When an environment has a complex replication infrastructure where changes are made frequently at multiple sites, the configuration can only match across a few of the SEPMs at any one time. This is the reason that considerable planning must go into site design and its impact on replication. Distributed management. In this example, additional network connections and bandwidth are required to directly connect Munich and Paris. This type of replication results in each site replicating with all sites. The end result is the same as hub and spoke. However, the data converges more quickly at the cost of additional connections and bandwidth. Centralized logging. The following slides discuss the different data replication types and how they combine into different configurations. In this scenario, unidirectional logging is enabled for logs. London can view logs and reports based on events gathered from all sites. Munich and Paris only create logs and reports based on their site's data. Centralized logs provide a way for companies to audit the Symantec Endpoint Protection architecture from a central location, provide security of data, so that different internal organizations can see their own logs but cannot see logs from other internal organizations. Provide a central location to track issues that are shown in the logs. Track resources within Symantec Endpoint Protection architecture. Client packages and content updates. In this example, client packages and content updates are replicated to ensure that all clients receive standardized configurations and content updates. The slide shows that clients receive the same installation packages across the organization in addition to policies and groups. If the environment is configured so that Paris and Munich retrieve content from the Internet, content update replication is redundant, but is useful when a site has issues retrieving content. If the environment is configured so that Paris cannot retrieve updated content from the Internet, Munich controls content updates and distributes them to Paris. Client packages and content updates are always bidirectional. When implementing replication, consider the following best practices. Ideally, keep the number of replicated sites below 5. Symantec strongly recommends that you do not exceed 10 replicated sites. Minimize the number of SEPM sites for replication by considering the use of a group update provider, or GUP, or internal live update server to provide content updates to dispersed clients. Only use multiple sites when you have field or organizational constraints. The Architecting and Sizing the SEP implementation lesson covers the key criteria for architectural choices. Have the SEPM at each site retrieve content from Symantec Live Update or internal Live Update instead of replicating client packages and Live Update content. Ensure that when possible, replication of log data occurs in only one direction. For example, if you have 3 regional SEPM sites, logs are forwarded to the central SEPM site. If more than 3 sites are replicating, or if there are more than 1,000 clients, Symantec recommends replicating no more than once per day. Ensure that replication schedules do not overlap with another site's replication or a scheduled live update session. This is the Configuring and Scheduling Replication topic. To install a new Symantec Endpoint Protection Manager and MS SQL database for replication with an existing SEPM using the Management Server Configuration Wizard, follow these steps. Select Custom Configuration. Choose to install an additional site. Name the site. Populate the server name, server port, web console port, and server data folder fields. Also populate the replication server, replicating server port, and administrator name and password fields. Type and confirm the password in the MS SQL Server fields. Before configuring replication for the first time, to reduce the amount of data that is initially replicated, you can reduce the number of content revisions to keep. To reduce the number of content revisions, select Admin, Servers, Local Site. Right-click Local Site, select Edit Site Properties, and select Live Update. In the Disk Space Management for Downloads field, reduce the number of content revisions to keep. After the initial replication completes, return this parameter to its original number. When you install the second SEPM as an additional site, during the initial replication, groups and policies and client packages and live update content are replicated. On this slide, you can view the message that is shown during the initial replication. On the admin page, under the Servers tab, you can review the logs to verify when the initial replication is complete. You can also review this information from the Monitors page, under the Logs tab, using the Server Activity filter. Log replication is covered in more detail later in this lesson. After the initial groups and policies are replicated, you need to log on to the newly created SEPM and configure replication. If you do not configure these parameters, further replication does not occur. To configure replication, select Admin Servers. Under Servers, expand Replication Partners. Select the site under Replication Partners, and under Tasks, select Edit Replication Partner Properties. The Replication Partner Properties for site name are displayed. When configuring replication, you have the option to replicate logs only. You can replicate logs in one or both directions. When you enable one of the settings to replicate logs in a direction, the options are phrased in reference to the SEPM on which you are currently authenticated. You can also disable replication of live update content along with client packages. Finally, replication schedule frequency is set. Replicate logs from the local site to the partner site. Configures the replication schedule to replicate logs from London, the local site, to Paris, the remote site. Replicate logs from this partner site to the local site configures the replication schedule to replicate logs from Paris, the replication partner, to London, the local site. While individual logs are very small, they can become quite large during an initial replication. Subsequent log replications are always much smaller. The size of all log entries stored in the database depends on several factors. The number of SEPMs and clients represented in the database to be replicated. More machines means more events overall. The duration of time that this environment has been in place. If the environment is new, log data is minimal. The amount of time that the database is configured to retain data. If the environment has been established for a long time, a large number of logged events has accumulated. The types of events in the databases. Different events contain different data, and so each event type is a different size. When you configure a replication schedule, client installation packages and content updates are selected for replication by default. This data only replicates in both directions. One thing to consider is that content updates and client installation packages are the largest data types to replicate. Typically, unless you are in the middle of a rollout, client installation packages are infrequently updated. One client installation package is approximately 80 megabytes. Content updates include content that is updated frequently. For example, Symantec posts new virus definitions 2 to 3 times per day. Virus definitions are approximately 100 megabytes in size when compressed. When the schedule is configured, you can choose to auto-replicate or replicate on a schedule. Auto-replicate. If selected, replication occurs every 4 hours. This interval cannot be changed unless the auto-replicate option is disabled. Automatic replication only occurs when there is a change in data. Replicate on a schedule. Choose to create the schedule by configuring the following settings. Replication frequency is hourly, daily, or weekly. Hourly replicates at each hour or specific hourly intervals. Daily replicates at a designated time, such as 12:30 a.m. Weekly replicates every week on a designated day and time, such as Sunday at 12:30 a.m. The admin page in the SEPM is used to perform replication tasks. Replication partner tasks include add existing replication partner. When you add a replication partner, the partner must be a SEPM that has been previously installed as a replication partner. For example, if the replication link between London and Munich is deleted, use this option to restore replication. This option also restores associations with the site that has been deleted from remote sites. Delete replication partner. When a replication partner is deleted, only the replication link itself is deleted. The site continues to be listed under remote sites. Replicate now. Select this option to initiate a replication with the selected replication partner. Cancel replication. Select this option to cancel a replication with the selected replication partner. Check certificate. Select this option to check a certificate with the selected replication partner. Edit replication partner properties. When editing properties, you can change the replication schedule and enable or disable the replication types. For example, disable logging. You can also use the admin servers page to perform the following tasks on remote sites. Import and export server properties. Edit server properties. All server properties are remotely configurable. Edit site properties. All the site properties are remotely configurable. Edit database properties. All database properties are remotely configurable. Delete remote site. Deleting the remote site removes the site from the remote sites list and deletes any replication relationships between the local site and the remote site. All other selections, such as Configure Secure ID Authentication, are invalid for remote sites. When you select an invalid command, the console warning shown in the slide is displayed. This warning indicates that the function is not supported for the remote site or server. You can directly connect to the SEPM to perform these types of remote tasks. This is the load balancing and failover topic. Failover and load balancing configurations are supported for the Symantec Endpoint Protection Manager. Failover configurations are used to maintain client communications if one SEPM fails. Load balancing configurations are used to balance client communications across 2 or more SEPMs. Controlling load balancing and failover is done using management server lists and can be customized by group and location. Failover and load balancing installations are supported only when the original SEPM uses Microsoft SQL Server. Do not install servers for failover or load balancing when the original SEPM uses the embedded database. Installing and configuring servers for load balancing and failover is a multi-step process as follows. On the additional SEPM systems, install and start the Microsoft SQL client on the computer so that the new SEPM system can communicate with Microsoft SQL Server on the other computer. Install Symantec Endpoint Protection Manager on the computer and add the new SEPM to an existing site, as outlined earlier. Configure policies to define failover or load balancing. By default, a management server installed for failover and load balancing is configured for load balancing, where both servers share the same priority. If you want to change the default after installation, you need to configure the priority with the Symantec Endpoint Protection Manager console. Apply the management server list. To configure load balancing or failover, in the console click Policies, and in the Policy Components pane, click Management Server Lists. Under Tasks, click Add a Management Server List. In the Management Server List dialog box, under Management Servers, select Add New Server to select the first SEPM to add to Priority 1. To add additional servers, to configure load balancing, add additional servers to Priority 1. To configure failover, select Add New Priority, click and highlight Priority 2. Select Add New Server, and add the additional server addresses. Next, apply the management server list. This slide summarizes this lesson. For more information about the topics discussed in this lesson, refer to the resources listed on the slide, and remember to frequently check the Symantec Support website.